Hello everybody. So this is going to be just a kind of quick introduction to the class, um, and then we'll get started with our first real lecture. So this class is Math or CPSC 7, and it's called Discrete Structures. So when we talk about discrete math, what are we talking about, basically? That's what I want to talk about in this lecture. So in math, there is what we would call continuous math. And what continuous math is what you use in a calculus class or even an algebra class usually. So continuous math. This is kind of your quote unquote normal math. All right. When you have a function, right, like you say like f of x equals, whatever it is, like, sine x plus x squared, in that case, x is allowed to be any kind of real number, right? So, so in something like this, in a function, x is allowed to be any real number right? And specifically, the consequences of being able to have any real number is that, in any kind of interval, there are infinitely many possible real numbers, right? In something like this, in any interval, such as, let's say, 0 to 1, right? There are infinitely many possible x values, I'll say possible real numbers, and even there's another property that between any two real numbers there's another real number. So that's another interesting property. So in an interval such as 0 to 1, there are infinitely many possible real numbers. And between any two real numbers, no matter how close they are, for example, let's say like 1.000001, that's a number, right? And 1, there is a real number. And that's just a property of the real numbers, that between any two real numbers, there's a third real number. And so this kind of setup here is what we would call continuous mathematics, because an interval like 0 to 1 would be a continuum. So a continuum is just kind of this case that we're talking about here, where between any two of these things, there's another one. So that makes it impossible to actually list them all out, because, where would you start? If you have a couple of them, if you take one and you take another one, there's one between them. Okay, now if you take two of those, there's a number between those, and so on and so on. And when you're doing math this way, that would be, continuous mathematics with continuous functions, or mathematics on a continuum. That is specifically not what we're talking about in this class. So in this class, we talk about discrete math. So this class deals only with discrete mathematics. Now, notice the spelling of discrete. It is not this discrete, right? This is not this kind of discrete, right? This kind of discrete here, this is what you use when you're, trying to meet somebody discreetly. Like wherever I was going to use an example of like meeting somebody somewhere for some illicit purpose, and then like I don't know anybody and I couldn't think of anything like mysterious or improper. So I apologize. I'm far too boring for that. So, but the point is that somebody would do that, and if they did, they would need to be discrete. But that's not us. We have no use of that because we're mathematicians. What we're dealing with is discrete mathematics. So discrete mathematics just means any kind of mathematical objects that you can list out and there's kind of gaps between them, right? So this is going to be math that deals with sets basically of separate elements. And typically there's kind of gaps between the elements. They don't have that property that between them there is something, okay? That don't have the between any two there is a third. Property. And so there's lots and lots of stuff like this that we could be talking about, okay? And we're just going to kind of, in this class, go through and learn about some of them, right? So examples of things that fall under the category of discrete math. Discrete math. All right, so what are some examples of discrete math? Well, first of all, we could have number theory. So number theory specifically deals with whole numbers, no decimals, okay? So number theory. For example, things like this. So like, example, what would be an example for number theory? Like something like this, two odd, like if you add two odd numbers, odd number plus an odd number is an even number, right? And that's discrete because whole numbers are discrete, right? Between any two whole numbers, there's not a third whole number, right? Like between 1 and 2, there's not a whole number. So that counts as discrete. I don't know why I wrote that EX there. That's an example. What else could be discrete math? So something else that could be discrete math would be set theory. So I'm not really going to do much for set theory. I'm just going to say like, well, what set theory? Like, there are, let me think, like 8 possible subsets of the set. And I'm just going to list a set, ABC. Why is there 8? Well, we'll learn that. Okay, and the point is that this is discrete mathematics because this is a set that has 3 elements. There's only 3 elements. Between A and B, there's not like some third element that's between A and B, that kind of stuff. So it's not a continuum. It's just a set of 3 things. Okay, so that's an example of discrete math. What's another one? How about graph theory? Okay, so graph theory would be dealing with graphs, obviously. Graphs specifically have to deal with a vertex set, so like a bunch of dots in space, and then these vertices are connected with lines that we call edges. And so which lines? Well, I mean, it depends on the graph, right? But so there's a graph. Okay. So something like that. And again, it's discrete mathematics because there's a finite set of vertices. There's no property of between two vertices there's another vertex. There's no property that between two edges there's another edge, nothing like that. So all of these kinds of things just fall under the umbrella of discrete math. Okay. Now what we're going to be doing is we want to be able to prove theorems about these kinds of things. Prove theorems about number theory. We should be able to prove that an odd number plus an odd number is an even number. We should know what it means. We should know that there's 8 possible subsets of the set ABC because we know how to make all of the subsets of the set ABC. We should know something about graph theory. Like there's some relation between the number of edges and then the number of like what we call the degree of each vertex and stuff like that. There's all these theorems that have to deal with all of these discrete mathematical objects, and we want to be able to prove those theorems, okay? So we want to be able to prove theorems about discrete mathematical objects these objects. And also what we want to be able to do is we want to be able to make computer programs that will perform algorithms involving these things. So we want to be able to prove theorems about these objects and construct algorithms for doing useful things with these objects. Now, what kind of algorithms would deal with discrete mathematical objects? Well, I mean, there's lots of them, right? Like, if you have a list is just a set. You could sort the list, right? That's something you might want to do. And so a list would fall under discrete math, and you might want to sort it, right? So what kind of algorithms? Like sorting a list, algorithms. Sorting a list, finding subsets. On a graph, you could, like maybe we're trying to get from one point to another, like that, and maybe we want to, take every edge, for example, or we want to visit every vertex or something like that. So sorting a list, finding subsets, finding a path in a graph that does something. Etc. Okay, so and those kinds of things we're going to be implementing on computers. So the first part of this class, what we do is we learn a little bit of what's it called, logic. And then once we know some logic, we'll learn about some of these specific types of discrete mathematical things. And when we do that, we're going to learn about some algorithms, and the algorithms we are going to program on a computer in the MATLAB programming language, which we will talk about on Friday. So let me say a little bit of that, write it out, and then we'll go. So the structure of this class is kind of as follows. So structure of the class. Not really the structure, more the schedule, but so what we're going to do is, number one, we're going to learn symbolic logic. Why do we learn symbolic logic? Because that's how you construct proofs. So once we learn symbolic logic, we can use logic to learn proof techniques. Okay, Now, once we can prove things, then we can actually go and learn about different types of mathematical objects. And we're going to, let's see, go through different chapters. Different chapters in the book, learning about different types of objects. What kind of objects? Well, we already said some of them. Sets, graphs. What else did we say? Sets, graphs, like integers, number theory, etc. And when we go through those chapters learning about those different things, we'll be able to prove the theorems. And that's really what this class is good for in terms of if you're a math major type of person. Okay, and so that's kind of the key, is that we can prove theorems about these kinds of things here. Okay, and if you're a computer science major, you still are going to get a lot of use out of this, because as a computer science major, you will have to make proofs in your computer science classes. And if you're a computer science major, you're not going to have very many classes where you have to do that. That means you're going to be a junior or you're going to be a senior in computer science, and you're going to take a class and they're just going to be like, oh, you need to prove this with induction. And you're going to be like, oh crap, what's induction? Well, you'll know what induction is if you take this class, right? And so the proofs in this class will really prepare you to be able to do the proofs in other classes. At a lot of schools, this class is kind of the first, I'll say, real math class that you take, because you can argue that like calculus is just, it's like, oh well, calculus is just numbers, right? I mean, it's like you do some integrals and stuff. It's just manipulating the symbols. You're not really doing proofs and things like that. And some people would argue that proofs are what real math is made of. And so for most people, this is their first real math class, right? So some people, oops, that's not words. Some people say that everything you do before you learn proofs is not real math. Okay, only proofs are real math. I don't believe that. But some people do. And so if you're going to be a real math major, now when I say a real math major, I shouldn't have said that. If you're going to be a theoretical math major, so like you transfer to like Fresno State or somewhere and you say, I am majoring in math, not applied math, not engineering, nothing like that, just math, then it'll be a theoretical math class or theoretical math major, and you'll probably have to take like 10 different classes, and all of them will be proof-based math classes. And that's why people say that, like, oh well, you take these calculus classes as an undergraduate, but everybody's taking calculus because you need calculus for, you know, every science major. But when you get to be a sophomore, or well, not really a sophomore, when you get to be a junior and a senior, you just crank out these proof-based math classes. And so that's why people say, oh well, that's real math. It must be real math because that's what the math majors are doing. Okay, and so like I said, it could be like 10 classes. Now if you're not a theoretical math major, you're not going to have 10 proof-based math classes that you have to take as a junior and a senior, but you're going to have some still. because you need them for other subjects as well, such as computer science and applied math and engineering and physics and so on. But just keep in mind, proofs are important, and you haven't done many of them before now. So yeah, so that's kind of the structure of this. And then I'll just say it. I know we wrote, or I said it, but we didn't write it. So yeah, as we go along, any algorithms we come across for doing things. As a mathematician, I don't like doing anything useful, but we will. Any algorithms we come across, we will code in MATLAB and try them out. All right, and that's the class. Okay, so there you go. That's just kind of a really basic introduction to what we're going to be doing. Not continuous math, discrete math, okay, which deals with sets of things, basically. Okay, so let's stop here, and I will do your first real lecture in the next video.